All right, so yeah, so colligative properties depends on concentration. So what is a colligative property? Colligative property, all we really care about is boiling point and freezing point, but oops, there's a P there, freezing point. So BP and FP, freezing point and boiling point. But also, for in parentheses here, VP, vapor pressure, is affected as well. So I will explain that, but the boiling point and freezing point are the most common. You learned about concentration already, so that's why I teach that first, so you understand what that means. Okay, so here's the easiest way to explain this, and I know I'm squeezing it in here to this little area, but I want to show you something. So draw 3 beakers. They're supposed to be all the same size. That was pretty crappy drawings there. All the same amount of water, let's say. Again, it's not perfect. But let's say this one here is just pure water. Okay, so H2O. H2O liquid. Over here, let's say it's 1 molar NaCl. So 1 capital M NaCl. And let's say this one is 2 molar NaCl. So twice the concentration. So I'm going to put dots inside my beakers here to represent the salt, the Na plus Cl minus. Would I put any dots in the pure water? No. Which beaker here, the 1 molar or 2 molar, which one would have more dots? The 2. So I'm just going to put 5 in here and 10 here, right? So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll have twice as many dots representing twice the concentration. Is that fair? Does that make sense? Okay. So what the colligative properties are all about, add a solute, salt's a solute, boiling point goes up, freezing point goes down. So you're stretching the scale. Water freezes at 0 degrees, boils at 100. Okay, so I know I'm running out of room here, but let's put that underneath. So BP is going to be 100, and then freezing point is going to be 0. Again, I know it's squeezed in here. Let me know if you need me to repeat or write something again here. Salt with 1 molar, salt with 2 molar. Here's what I'm trying to get you to see and understand. The boiling point, so look up here, the boiling point of both of these solutions are going to be higher than 100. But the 2 molar is going to be even higher because it depends on concentration. So a higher concentration means the boiling point goes up even more. So the boiling point here, let's say, is 105, and the boiling point here, let's say, is 110. So the boiling point goes up even more the more salt we add. And then the same thing for the freezing point, except it lowers. So the freezing point for 1 molar, let's say, is -5, and then the freezing point for 2 molar is -10. So you're stretching out that scale. Instead of 0 to 100, we're -5 to 105, -10 to 110. I'll explain further, we still got some time, but I'll explain further after the video and then tomorrow again why the boiling point goes up, why the freezing point goes down. But bare minimum, the reason I show the video like 3 times, you'll see it again tomorrow, I need you to memorize colligative properties, depends on concentration, and then add a solute, boiling point goes up, add a solute, freezing point goes down. If you can remember those 3, memorize those 3 things, you can get a Regents question right. Doesn't mean you really learn the chemistry and understand what's going on, but let's be honest, we want to get the questions right too. So that'll help you get the question right, and then, you know, when I explain it, hopefully that makes sense to you as well. All right? And that's it for colligative properties. All right, we just got a little more notes with that, then we're kind of done with this solutions unit, and we're going to be moving on. All right, so sodium acetate. They have some crazy music playing here. I think this is Adam's favorite song, actually. They're going to pour the sodium acetate into these Petri dishes, and it looks, I don't know if you can tell, but it looks clear, right? Yeah. There's no precipitate, no solute, no solute floating around. It's all dissolved. Well, it's supersaturated, and then what they do is they pour it onto the Petri dish, and on the Petri dish there's a very small crystal. So as soon as the solution touches the seed crystal, it instantly crystallizes, and this has so much solute in it, it basically just looks like one solid tower of crystals. The water looks like it kind of goes away. So you're going to see it crystallize instantly, and it's the same principle of rock candy. Adam, this is your favorite song? Yeah. So that's basically a giant crystal of sodium acetate because it's precipitated. That's what's happening, it's precipitated. And there's so much of the sodium acetate, it's almost like the water goes away. The water's still there, but it's mostly sodium acetate. It's kind of crazy. And then watch when he pours, or she, I don't know, he or she pours more on top. You can actually form a tower of it, and it starts climbing up because it's crystallizing instantly. So I've done this. It's more fun to see it in real life, but it's really hard. And the video is just more of that. But the reason it's hard to do, and I don't think the video can see this here, right? This is off the screen, this thing, right?
You just touch it.
Yeah. So this solution is very unstable. So if you make this solution and you let it sit on the table, and I did this. Remember one year I made it, and then I had to leave and go do whatever. I didn't need it for the next class. Kids came in here or something happened. Even me walking around kind of caused the floor to shake. And if you shake that solution, it can crystallize. So it's very unstable. So every time I made the solution, I would get it to dissolve for like whatever, a couple minutes, and then it would just, I'd leave and I'd come back and it's all like this. And I'm like, what the hell? So I couldn't get it to stay long enough to show the demo. And then I finally got it to work again like twice the entire time of the teaching. And it's very hard because if you use dirty, you can tell these are really clean. They're probably brand new. If you use dirty glassware or glassware with scratches, the scratch will be a surface that the crystals will crystallize on. You ever notice how certain ice crystals form, I don't know, on car windows or windows of your house? Like there's certain spots where there's crystals and some there's not. Those are probably divots or scratch or something with the window that allows the ice crystals to form. It's the same concept. So it's pretty cool. That's what supersaturated solutions do, and that's what rock candy is all about. That's what rock candy is. It looks very different. And the reason for that, this is actually a little advanced concept, but can you see these striations? Okay? That's what sodium acetate crystals look like. So when you take the sodium acetate ions and make that crystal lattice, the repeating structure, that's what it looks like. Sugar looks like little cubes. So it's just the way the particles are arranged makes the crystal look different. That's kind of cool, I think. So anyways, I wanted to show you that because I can't really get that to work in real life. But we'll stop there. We'll pick up with this tomorrow. Don't forget the 2 worksheets. The one was not homework, right? Just review. The other one is homework, all right? And I don't think I have a meeting or anything, so if you are after school and you have a ride or whatever, or sports or whatever you're doing, I'll be here. And that's it.